Hello, hi Vasundhara.
Yeah, hello Sneha. Good evening. So yesterday we have seen this dictionary and all this thing. So have you practiced Sneha? Any question is there?
I didn't get time, but yeah, I understood the concept. I will practice this weekend. And one more thing, Vasundhara, I have to drop out from the session by 6. I have a call.
Okay, fine. So we will start now already. I joined late already. One second. Yes. Data visualization. So we have to go for second. So what is the conditional statement like if else? And in conditional statement also, how to implement that? So basic if else logic, you know that. Like if we take some example like this, so first it will check the if part, and if that is matching, the condition is fulfilling, then it will print those things. And if it is not fulfilling, then else part will be print. So if we want to write the else if later, like if condition fulfill, then do that. Else another condition. If that is fulfilled, then do that. If then another condition. Like that, we can go on writing any number of condition, and at last we can write some default thing. Like if does nothing is no condition matching, then populate this data, or print this particular data, like that. So in Python, there is the elif is there instead of else if, elif that is there. If you want to put further conditions and printing something. So yeah, we can write condition inside condition also. If this condition, then this condition, then this, else that, and else that, like that, nested else. Yes, so this was if else. Similar to if else, there is a match case or switch case is there. Like elif ladar was there, like that only. So here you can write the condition match, like this is the syntax match, then choice value, and if the case value is this, then do that. Then case value is this, then do that. Case this, like that, n cases you can write. Yeah, this is one example. So it will ask input from the user choice. So if user will enter 1 to 10, 1 to 9. So first, if it is 1 is entered, then it will print something. Then case 2, if 2 is entered, then this. You can write many statements also that will be printed. Match case is also like elif. But if we have lots of choices and we want to print that, or we want to use that conditions one by one, then we can use that case and when. So like that up to 9, and this is the default which need to compulsory give underscore. So if it's some apart from 1 to 9 and anything else is printed, then it will be executed. That is case match, and then case this, then print this, like that. Okay, then next, this was simple, so I didn't executed this. You can try to do that all executions. Any question up to now?
No.
Yeah. So while loop and for loop next is.
Vasundhara, I have one question. For yesterday, you have provided some word one for the
Yeah,
for set
dictionary.
operation. I have
Okay.
no for the set one.
Okay.
So I have one single doubt only. Can you open it? There is some exercise, set operation exercises. The that sheet name is not this one.
Yesterday, which one I
Yeah,
gave?
just above one. Just above one. Whatever you selected, no, just above. Yeah, this one. So in this one, while executing of any one of the set, like in a union or any one intersection, they're not giving a output as a in a sequential order. It will give any one of the order. So is this
Yeah,
a
yeah.
property of this set?
Yes, that's what. It doesn't store the data in given order. Like if we are giving or it like this 1, 2, 3, 4, 5. If you print it, then it can print 4, 5, 3, 2, 1 or 2, 3, 4, 5, 1.
Mhm.
That is there. That is property of set.
Okay, okay. Okay, that's it.
Yeah, that's what unordered collection it is. Whatever we give in input, whatever order we give in input, it is stored in different, but it will store
Okay.
all the
And
value,
is there,
everything.
yeah, but is there any way to like while printing the output, can we order those output?
No, then you need to store it into the list or any other tuple like that. Set
Okay.
will give like that only.
Okay.
Yeah. Now we are learning the if-else condition and matches in case I just explained quickly because it was simple, so I didn't execute it. Then next is while loop and for loop. That is the important concept. So, what is the for loop? We have used it many times, right? For creating list comprehension or dictionary comprehension, and what is the tuple comprehension? With that also we'll see. So, for creating list tuple and dictionary, we can do use of the for loop with range, with the combination of range. Many times we used for loop. So, like that. And while loop is also for what is the difference between for and while? So while loop we can use with conditions equal to true like that, and we doesn't know that how many runs it is. It's not fixed number of run. Then we use the while loop. But if we have a fixed number of run, then we use for loop n times. So if we want to execute for fixed n times, we can use either while or either for. Both is possible. But if the number of run is unknown, then while can be used till something is true, till something is false, like that. When we condition is become false, then while loop will stop. So it is condition based loop. While is totally condition based loop in Python. In Python, any loop needed to create on the basis of condition, then we will create using while. So condition based, like till the condition true or false, like while we will give, while that condition is true, till that time it will be go on running. So it can run 5 times, 10 times, 100 times, depending on the condition. And different times, maybe different condition. So same conditions may vary different times. So that's why the number of run is not fixed in while, and it is totally condition based. It is also called condition based loop. Then how to create the syntax is simple: while, condition, colon, and whatever you want to write, like this. So suppose we want to write some while some condition is true, like that. Why we want to print something, or here they have taken a very simple example, like incrementing the one variable till it is becoming 10 and printing the values. This can be done by for loop also, right? So what is the special of while? Um, so if you are taking a is equal to something and incrementing it till certain condition, right, that can be done by for loop also. But if such type of condition is there, like till that is uh, less than one, or less, some, like the file will be giving records till that you go on, like that is type of condition, then while is compulsorily need to use. But this all type of use case you can do either by for or either by while. Yeah, you can give conditions also inside if you need. What will be the resultant of this one? So a equal to 1, right? A less than equal to 10. If a is greater than equal to 5 and less than equal to 10, and this, then print a else a equal to a plus 10. No, no, no. It's not a equal to a plus 10. They are not incrementing a at all. They are just a plus 10. If we will do like that, 11, 12, 13, not 11, 12, 13. A will be like 1 only every time. It's just printing the value 11. It's not giving 2. So a will be always 1, right? It will never be incrementing till 10. It will be less than 10 always. So it will be infinite loop. Then this one, and it is incrementing it. A plus equal to 1 means a equal to a plus 1. So what will happen here? First of all, a is 1. So this condition is not fulfilled. It will print 11, this 11, and it will increment it with 1. So 2 it will become. So 12, 13, 14. Then when it will become till 14, it will print. Then it will become 5. So 5, then it will match this condition. But it is not, modulus 2 is not. So 15 also will be print. Then 16, it will match the condition. So 6, it will print like that. 6, then 7, 17, 8, 19, then 10, it will become 10, then 10 modulus 2 is 0. That's last, right? That will be last. 11 onward, it will not print. So like that it will, what will be the output? Sometimes this kind of questions are also asked to predict the outputs. Yeah, let's see, we will write some loops and So suppose if we need to print something like star or L, yeah, like that many questions are there you can try to do if you want. Before moving for loop, we will print something like how to print dots or stars like this. Then like this. Okay, like this kind of stars how to print. 1, 2, 2, 3, how to print like this. This will be a practice for while loop, like while I equal to 0, like you can print a dot or star. Print a star, right? Then 1 star, 2 star, 3 star, 4 star, like that. How to print? It's simple actually. It's simple. Anything you multiply, um, not star into a. Sorry, star into a, like 1 time, 2 time, 3 time. So I have to k equal to 1 in starting. Same thing I think you can do by for loop. For I in range 5 or 1 to 5 or 1 to 6. This thing. Let's see. No, it's not. One, 2, 3, 4, 5, like that. And here what is happening? I in range of 1 to 5. Yeah, I should print I. Right? If you give a space, right? So this is easy. Now, how to print that one? First, this one. How to print this one? Instead of star, you can print 1, 2, 3 like that, like value of A by converting it into string, right? String A into A, right? If you convert it, then it will behave like a string one, not the that. If you without converting string, if you will do, then it will multiply. 1 into 1, 1, 2 into 2, 4, 3 into 3 into 3, 20, 27, like that. If you without converting string, if you do that. Next, this one. Here we have what is happening here. Like first time it will have a 1 space, 2 space, uh, yeah, 2 space and a dot or star. Then 1 space and this. There is a space also we should take to be reducing order. Like you can use loop also incrementing, like to loop inside the loop. Yeah, this we printed. And here if we use this is while loop. So while a less than equal to 5, if we take one more loop, zero, then print. What is B? First time A is 1, so B is 5 minus 1, 4, then 1 second. Instead of while loop, can we take 5 minus A times space and or 5 minus 2 times space. Yeah, like it's printing the 5 minus 1, 4 space here. Then 3, 2, 1, like that spaces. When it is 5, then 0 space here. 1, 2, 3, 4. 5 minus 1, 4 space. Yeah. This space is of star only with a star, but this onward 1, 2, 3, 4. Then, yeah, this is 4 spaces. Then 3 spaces. Then 2 spaces. Then 1 space. This one, I think. And 0 space. This space is of star only, but apart from that, something like that. So last, when a equal to 5, then it is printing 0 space, but 1 space will come from here. So space star, like that, into a means 5 times. So this 1, 2, 3, 4, and 5 times, like that. Right? By printing different things, we can learn how it is working. Right. Then how to check whether a number is prime or not? For that also we can use a loop. Now, yeah, so a is less than equal to 5 and a plus 1. We can do this thing by for loop also actually. We can use a range of 5, right, and print this like that. But certain things are there which can be done only by while loop. Suppose, yeah, how to print primes or how to check primes. Yeah, how to print first 20 prime numbers or first 100 prime numbers. Yes, or check if something is prime or not. Yes. How to print first 20 numbers, suppose. For loop, if we use I to 10, I less than 10, or for I in a range.
Range 1 to 21.
Yeah, 1 to 20 or 0 to 20, or we know that 1 is not a prime. So if we start from 2, so it will
Okay,
print
first
2, 3,
20
4.
prime.
Yeah, so suppose if we go to how many things we need to print? 2 onward till 20 prime. That means how many numbers we have to take here? 2 to the power or um, 2 plus 1 or something is there. Suppose we will take till 30 or root 2. What is the value of under root 2? Suppose 30, up to 30, we will see that. And if it is there, then there is some formula actually. By that we can check that first 20 prime means that much, like that. Range. So okay, 2 to 30 suppose, like that. And if we will print this number, it will print this 2, 3, 4, 5, 6, 7, 8, 9, like that, up to 29. How to check prime numbers now? What is the prime? What is the definition of prime?
A number which is divisible only by itself.
Hmm. That means we need to, it is, what? It is not divisible by 1 and, if, yeah, it is divisible by
No, divisible by one and
1
itself.
and its own. It should
Hmm.
not be divisible by any other number other than its own. And so we can check till, suppose there is a number we are taking, and we can check it up to what number? Suppose 3 we are taking, or we take 5, big number. Then we can go on dividing it, modulus I or modulus j, whatever. So 1, 2, like start from 2. If it is divisible, that means it's non-prime. Then we will check with 3, right? So up to what time we should check it?
Till
Root,
20.
no, we need to, ideally we need to check it with 2 or 3 or 4, n minus 1, right? But for reducing the, I will check till n minus 1, but there is one more like one more performance reducing technique is there. You can check till root 5. Till that, root 5 means what is the value? Half value or something, that like that. Till that you can check, it will return you the value. You don't need to check even up to n minus 1, like that. So, but okay, for simplicity, or for we are learning first time, so we'll check till n minus 1. That means till 4, right? Like 6 is checking. So 6 is in starting only, it's divisible by 2. So if it is divisible, then stop it there, suppose. So we will start with suppose some number equal to 2. 2 is already we know 1 is not a prime. 2 is prime number. From 2 onward we'll start. So for I in range starting from 2 till whatever num is there minus 1, till that. Yeah. Um, but it should not be 1. So what is there here? 2, already we know that 2 is
First
2
one, we
modulus.
know.
Yeah, but how to check for 2 if we need to? So, um, and any number if we will use, we should do n minus 1. Oh, here, just a minute. Yeah. So what to think here? 2, so we need to try to divide it with 2 or 3 or 4 or 5. And when there is a break statement is there, before that only we will break if it is divisible. So we will increment I starting with 2 till n minus 1. 3 minus 1 is 2. 2 minus 1 is 1. So start with 3 better. Because 2 minus 1, actually we have, we can do till root n plus 1, like that. So root 2 is 1.1. Root 3 is 1.71 plus 1. Root 4 is 2. So till 3, root 5. Either num minus 1 or root n plus 1. How to give root n? Under root n, like num to the power 1.5, and convert it into integer plus 1. It will match for 2 also. Like root n, root 2 is 1.41 something. So 1 plus 1, it will be start with 2 and till 2. That means it will print only what it will print. Let me check.
It should do 0.5.
No, integer will remove that point, means decimal part. It will print 1 plus 1, 2. If we print this value itself, what is, it's 3. That means root 2 is, how it is 3? 1.4 plus 1.41, yes. One 1.41 is converted into integer, it's giving 2, like that. If you take for 3, yeah, and we are doing till plus 1. So it will produce till 6, 2 to 6 values. So for 2, it is producing
3.
3, means here it will divide it with 3. It should not be, actually 2 is there, it num to the power 1.5, not 1.5, sorry, 0.5. That will be under root 2 here. 0.5 plus 1. Yeah, now it is dropped. 1 plus 1, 2. 3, if we give, then 3 also. We can do till 2 only. We can divide by 2 only. Then 4, so 3. That means 2 only will come here also, because 2 to 3, 2 only. Then 5, so 3. 3 means again 1 time 2 only it will divide with 2, 3, 4. 3 things we need to check with 5. So for 6, it will divide with 2 only. Then suppose big number, if we take 10. So 2 and 3, it will divide it with 2 and 3. And with 9, again. So 2, 3, and 4 will not be there. 2 and 3. So it will be till that it will become. So 27, 7, 49 till 8, right? Till 8, 7 will be there. So this number is like that. It will cover those particulars which will divide it. Like rare number, if we say 11, that is non, that is prime actually. 11 is prime, so it will check till 3. 17, 19, 13. Right, so we will check till here. Okay, and we will print what here. If it is like any time it is divided by 0, not divide by 0, modulus I. Modulus I means the remainder. Modulus operator we have seen at the time of operators. So if it is 0, that means it is divisible by any of those number which is in that range. Then we no need to print anything. Then we can just break the loop and make some particular, like we can take one status p equal to, which is true or false, like something prime. True we can take in a starting, and if anything is divisible then we will make it to false. And we will break it immediately. Break, continue, pass. Three things are there. Break will break the loop. Because if it is divisible, then no need to check further. Right? If it is not divisible, then only loop will go on checking and will not break it. Right? So yeah. After that, we can use one more if, like at the last, like loop is done, for loop has did all the testing of the numbers. So anytime if this p become false, that means we will not print that number. If p is after all test also, if p is not false, p is true, right, truthiness check, then we can print that number. Yeah, print num. So first time we will check for 2, then 3, then 4, 5, 6, 7, 8, 9. So what is num? Num we need to increment with 1, we need to start with 2, and we need to use here some loop. And so first time it will check for 2, all the check will happen, and then if it is found, then it will print it. If not, then it will not print it. And num will become num equal to num plus 1. So this entire we need to do in one, we need to take one more loop here till this 20, means till counter will become 20. Some counter we can take. Start with 0 and while counter will be 20. This is the uses of while loop. Like, 1 second, here we need to give an index. This count plus 1. Count, when to increment count? Not like num. Like if it is prime, then only increment the count, so that we will have 20 prime numbers. Otherwise,
Yes. Break the loop.
one Otherwise, num will increment third, fourth, fifth, but count will not increment.
So num will not part of that loop if loop.
While loop, it is part of while loop.
It will part of while loop. Okay.
Yeah, num will increment. Go on. While loop. Yes, this is part of while loop. This if and num. What will happen? Like count will be 0. Starting count will be 0. 0 is less than 20. So this while loop will check that num, and 2 is there. So 2 is prime. So it is printed. Count become 1. Now num is also incremented with 1. Num become 3. 3 also will be printed. Count will become 2. Then 4. Num will become 4. Now count will not, like 4 will be break this, and because it is break and it is false, so 4 is not printed. So count will not become incremented. Num will increment now. Right, so in starting both were 2 and 3 both incremented. For 4 only num incremented to 5, count didn't incremented. Then for 5 both will increment. 6 only num will increment to 7, count will not execute because it's not prime. That's why I have given counter here, because I want 20 prime number. That's why. So yeah, 2, 3, 5, 7, 11, 13, 15, 17. This all are prime only.
7.
Yes, this was actually a mathematical trick. We can check till root n plus 1. Root n plus 1 will be enough for checking from 2 or 2 to root n till that. So I have given plus 1 intentionally so that it will check that till root n. Otherwise, you can check n till n minus 1 also. It will be few more loops. It will be take few more loops. That's it. So what is the use of while? Here we don't know when count will become 20. Right, up to what it will be increment, how much number it need to go. See, up to 71 it has gone, so we don't know after how much number it will go till it will count 20 primes. Till 20 times it will be true, right? So it is condition based on this logic, internal logic. So that's why while is used here. Loop, so both while and for, what is the difference here? You can see it clearly, right? So if this is difficult, then till n minus 1 we can check, like till num. It will be num minus 1 till that. Yeah, it will also print you, but here the performance issue was there. Like it took more loops unnecessarily. Till root n only the work will be done. Even like suppose you need to check for 23. So 23 value 23 is this checking. So root 23 is how much? Till that only you can check instead of 23 itself. 23 you need to 2 to 23 means 2 to 22, around 20 time it will loop if you give num. Instead of that, if you give root 23, so it will loop till 4 times only, 4 to 5, around 4.7 means 5 it will tell. So 5 times only. So where is the 5 time, where is 20 times, right? It is told that till root n only you will detect. If it is prime, then it will be divisible till root n itself. So no need to go till n, till num. Okay, although it will give, both will give same result. Yeah. Okay, guys. So this is the clear difference between loops. What is the for loop and while loop? Uh, you can try this logic by yourself. I will just yeah. This is, I will say share you this thing. And this Monday, yeah, this Thursday and Friday, I think I may not be able to take classes. Tomorrow I will update you. Tomorrow class will be there or not. Yeah. So because I am traveling, some work is there. Thursday, Friday, definitely it may not be there. Class may not be there. On Sunday, I can take extra if all are available. Otherwise, from Monday we will start. I will share you this worksheet of for loop and while loop. You can practice that all. And for loop, we have seen this all right. For I in L1, print all, tuples printing, string character printing, then set value printing. It can, yeah, it can print you not 1, 2, 3, 4, maybe 2, 3, 4, 5, 1. Any set different, set used to print differently. That's why. D1, this is the what, like ABC. So here, what is this particular is name, email. This is the key and value like that. So if you want to print D1, it will print you the name and email rightly. If you want to print only key and value, so you can print the key in D1, right? Or element in D1. If you print like that, it will print you only key values, name, email, this thing, right? Name, email, like that. And you want to print value, then you need to give like this. And with end equal to space, yeah, then it will print you name space ABC, this ABC, then email space that abc@gmail.com, like that. So range, how to work with range, we already discussed and worked many times. So this all you can practice. These are simple things. Now break, pass, and continue. What is the difference? So break, just we have seen the uses of break, right? So break can be used for breaking a particular loop in middle. Like in our case here, it will be break the loop. If it is, yeah, here. So it will check like for 23, it will check till 5 times, right? So for 23, it need to check till last because it is prime. But for 22, suppose, for 22, it will check 22 modulus 2 is equal to 0. Yes, right? It will not check 3, 4, 5 then. It will break the loop immediately. It will not check for 3, 4, 5. Okay, it will just print this. Yeah, it's true. So print the 20, no, it's not true. 22 is not true. So it will, else part is not given. So that's it, done. Then num equal to 23. That's it. Counter not incremented. 23. It will check now while loop again. So counter is same, it not incremented, and it will check this loop again for 23 now. That is true, and it will be printed counter incremented, now make incremented to 24. 24 again, 2. By 2 itself, it's divisible. It will not check 3, 4, 5. That's why performance will be faster by break. It will break the loop if it is not useful. If condition is fulfilled in single time, then break it. Okay, continue means it will stop only that step. It will continue for next step. Okay, and pass is different. Like I will give you the examples here. Break, yeah. So you can use this all and see that all. I will write it and continue. So continue will skip that step. That's it. One second. Read it. Continue is used to skip the current iteration. That's it. Break will break all the iteration. Break entire loop. Like here, it will not move further. After it's divisible with 2, yeah, then it will not move further. But if you give continue, it will break only that step. It will not go ahead for that code, but it will move for next iteration for the loop for continue. Okay, and but not one second. Skip the current iteration, but not the loop. It will not skip the loop. Loop will continue. Only that iteration will be skipped. If we want to avoid or ignore any one iteration or any number of iteration of loop, then we can use continue. Like this. So suppose we will execute this quickly. What is happening here? A is till it is less than 5. If is equal to 2, then continue. So what it will do, on 2 it is skipped. This loop, while loop, it is skipped on 2. But it is continuing from 3 onward, 3, 4, 5, 6, right? If you break it, then it will break at 2. So at 2 it is break entire loop. Okay. Continue means only 2 is break. Third, fourth, fifth is continued. Clear? So these two examples. Is it clear what is break and difference between break and continue?
Yes,
Break
okay.
will break entire loop. Continue will break only the that iteration. Next iteration will continue. By name itself, it's pass is different. Pass is generally a placeholder. That's it. Suppose we need to define a function or a class or loop, but we don't want to define its definition at the moment. We want to like for loop. I want to define a for loop for I to I less I in some something, and I don't want to write any like yeah, everything is proper, but I don't want to write anything. So if I don't pass it, it will give me error. If I pass it, it will not give me error. Like if I don't do anything, it will give me error, incomplete. But it is for future use. I define one function, some parameters are there. If I don't define, it will give me incomplete. So I have just used for future use. Now it will allow me. So this 2 is having any uses here? No. For future use, I have just kept it, and because I didn't give any definition what to do for I is in this range or this list or this tuple or a string, what to do? I didn't define anything, so I can pass it. Similarly, function, similarly, class. If you define any class, then also. So you defining some particular object, but you are not giving any definition that is for future use, just keeping it. So you can pass it. Otherwise, it will give you incomplete error. A placeholder, that's it. We are working with the following if else also, while, function, class, loop. When we do not know what code we need to write at the moment. In future, we will write. Creating it for future use. Okay. At that, we will use pass. Or to tell the system there is no code currently. Like this, if a greater than 100, then pass it, else pass it, like that, something. It is some dummy code, but while loop with else block. Yeah, one more thing, with for and while loop you can use else block. So while is a loop, right? Like this. Here you can give else block, like here, else. So what is the use of that? That is special cases. So while working with while loop, we can use else. If we write else, then the else block of while will always execute after the while loop, but except when there is no break is executing in the while loop. If it is having any break and if it is executing, then else block of the while loop will skip or will not execute. And if we are continuing while loop, if continue is executed or not, else will compulsorily execute. Suppose here itself, this thing is just dummy. This one else part, else print hello. Right, so it is printing hello 6. If we will break it, then it is not printing because break is there. Right, so it will compulsorily will be printed last if it is not breaked. Loop is not breaked in middle. So this is a kind of checking purpose also, whether the loop was break in middle, so it will not print the value. If loop was complete, if break statement is there, but it was not breaked at all, right? There is no condition, but like that only break statement was not fulfilled at all. Like here, suppose a is greater than 6, that will not fulfill, never break. In that case, else will print. Okay, but if any break happen, then only it will not print. Otherwise, after execution done successfully, it will print yes, it's successful or something. So that is else part of while else, like that. While working with for loop, also you can use else. So the else block of a for loop always execute at the end of the loop, but except when there is a no break is executing for the same thing. So if any break, then else block of will be skipped or will not be executed. Same thing with for loop also. It is also having else part, while else, for else. So there here is some code, you can try this. Okay, you try this by your own. Very simple code. No logic, it doesn't have any much logic to think upon. Just a normal value incrementing. That's it. Then in Python, indexing we have learned already. List type, tuple, string range, positive indexing, negative indexing, all I have explained you in detail. We have learned this. So still, if you want to go through from this, you can go through with examples. So I will share you this, then you go through from this all. Then tuple comprehension. We have learned list comprehension and dictionary comprehension, right? Yeah, you can go through from this also. Dictionary comprehension, more nice manner. It has explained with very step by step. Then generator and expression. What is generator and what is expression? We know little bit about that. So um, we do not have any tuple comprehension like state comprehension or list comprehension or directory comprehension. In Python, we have a concept called generator concept. That is tuple comprehension, we can say. But that is not exactly, but it's giving tuple. Okay, this generator can generate in the following. Generate as a function or generate as an expression. So when we create a generator as expression, it looks like a tuple comprehension. It looks like, but it is not, but it looks like, and it is cost effective. I have sent you one message also in that Sunday or something, right? For tuple comprehension. Like here, we have used list comprehension, but not tuple comprehension. So it will give you a generator expression like this. Result I for I in this. If you use a list, it will occupy entire storage. But if you will use a tuple, then it will look like a tuple comprehension, right? But it will not print you the type tuple, it will print you the type generative expression, like generator, like this. So it is not tuple, it's a generator. And if you want to print it, it will not print you, you need to convert it into list. Now you can print. So result, yeah, this is, and this is list. Yeah. If you want to convert it into tuple, so same thing you can convert into tuple also by tuple function, set by set function. So this is generator. Once it is generated, this result set of 10, 20, 30 as a generator, you can convert it into a list, tuple, set, whatever you want. This is 3 type of conversion to generator. So what is the uses of generator? It is taking very less memory, just a few bytes to address. This is the address, that's it. When you are converting it, at that time it is expanding its memory. At the time of uses, like here, this is uses, list, tuple, set, these are uses. So at that time only it's, you don't need to give 3 time actually. It's unnecessary. One time is enough. But here, what happened here? Tuple, okay. You need to, why it is happening, Why empty? It has exhausted. Here itself it is exhausted. That's why you need to recreate one more. I will rename it or otherwise, but okay, it's good. So what happened? It is created here. Okay, you have used it, so it is exhausted here. Now if you will convert same thing into tuple, it will not be. It will be null, none. If you take it again, refill it again like that, then it will give you. So generator has some property. It's very interesting and very important concept. Generator, Dunder method. These are very interesting in Python. So generator has this thing. It has iterators, iters, and next. What is iters and next? We'll learn in detail. And this is very important property. If you use it, it will be exhausted. Two important property. It doesn't occupy memory. Generator memory at the time of creation. Okay, but if you use it set to create tuple or list or set or anyway, then it's exhaust. You can use it in a that also, what is called iter. So or anyway, like in iter and next, then it exhaust and will give null. Or if you use next, then generator is completed or set generator, something like that it will give. This is one property. Okay, and it um memory at the time of creating it, so it's occupying less space. So till uses, it's not um filling the memory or not occupying the memory. That's why good performance. Generator we use generally for that purpose only. Instead of creating list comprehension, we use generator. Later on, we convert into, whenever needed, we convert it. Slicing we learned in detail. You can go through from this. Again, some more examples are there for slicing. You can go through from and complete it. So that's it for today. Yeah. Tomorrow, if we will connect tomorrow, then we'll learn more, or you can complete this particulars. Then I will update you if tomorrow class will be there, or otherwise it will be on Monday directly, because I have to travel for some particular urgent purposes. Then we will start this thing, functions, on Monday. Yeah. Okay, then bye everyone. We'll conclude here.
Okay.